Okay, hello everyone. We're in part 4, OAK-D plus TouchDesigner. We're going to learn how to run other object detection models. This is following a part 3 where we looked at TinyYOLO, the default model that is on the OAK-D. So you might recall TinyYOLO can detect 80 different objects. Accuracy was kind of not so great for it, but by using this platform called Roboflow, we're going to be able to search for lots of other community-generated models, as well as create our own custom annotated image datasets. So let's have a look at that. So we'll need our NDI Python and Python OSC again. So definitely go back to all the other parts if you haven't done that already to learn how to get all that running. But let's look at, so what is Roboflow anyway? So it's focused on CV applications, and so it's streamlining the process between labeling your data and training your model. So that is really awesome. You can search through the Roboflow universe here that has lots of community-generated models, and we can kind of learn a little bit of how this works. So we're not really annotating in this part. I think we'll do that in parts 5 and 6 to learn how to scrape images and annotate and all that. But just some of these other community-generated models are kind of cool. This is Aerial Airport. So this has 338 images in it. So for all of these, people uploaded these images, and actual human beings went through and drew rectangles around every single airplane, and then in this case labeled it with the class airplane. So we did this for all of these images. So when you see something like this, you understand a little bit more the actual human labor that goes behind all this AI magic that people are obsessed with. So it still takes a whole lot of labor. So there's so many cool examples here, like in gaming. There's some cool ones. I like this double 12 dominoes. So you can see it's detecting the number of dominoes there. So this data set was a little bit less, 146. But you can kind of see, right, it's detecting all the different numbers. So this creator made an application you can just use with your smartphone. Like if you're actually playing dominoes, you like take a picture of the dominoes, and it'll add up the score for you, which is pretty awesome. So I like that. But what we're going to look at is this playing cards model, which has a huge number of images. It has 10,000 images. And you can see they're all kind of generated like so. So these are all kind of digitally generated images, but all with a kind of confusing background. But for the most part, you know, all kind of splayed out with 3 different cards. And then all the different types of cards you can test. So that's the model, but let's try it out. So we can try pre-trained model for any of these. So over here on the upper right. And then before we, if we're not really sure, maybe we don't want to do the labor of getting it onto our OAK-D, you can try it out just with a normal webcam by going to this page. So we can hit webcam. And there we go. Cool. Okay. So we can see it's a little latency, a little bit lagging behind, but whatever. I happen to have some playing cards. So I'm not a magician. I don't know how to really handle these properly, but whatever. Let's pick one. Okay, cool. And we can see over here predictions, class 5D. So it's accurately getting 5 of diamonds. Confidence is pretty high. And then we get bounding box. So okay, it's kind of wavering a little bit on the D. So you can see different examples. What about this one? 4S. Okay, cool. It's wavering a little bit. 4S. I just thought it was a diamond for a second. No. Okay, so more or less, these look pretty good. You can kind of see. Let's try 3 altogether. How well does that respond? So it's twitching a little bit, but for the most part, it's getting them correct. By their own analysis, it says it's 99.5% mean average precision, which seems like a really high percentage. Tiny YOLO is like down in like the 20s. So if you believe that, this is a much more accurate model. It seems a lot more accurate, in part because the 10,000 different images and also just the objects that it's trying to detect are just a lot more homogeneous, right? Just the playing cards are all kind of the same format, so a little bit easier for it to detect. But let's not look at that. We want to deploy it to our OAKD. So how do we do that? They made it super duper easy on us. I'm going to go ahead and click this here. Use with. So all these different platforms that you can use this model with. On-device deployment. So here is all the code we need. Just copy it, paste it into a Python file, and probably we want to put that inside the depth AI examples, maybe the YOLO examples, whatever. Just keep all those together, or object detection folder if you want to make one. And we can just copy paste it and it'll run. We will need to install this Roboflow Oak library here. And then in the magic of post-production, I will redact this here because this is my private API key. So you will need your own private API key on that. If you are logged in and have your workspace set up, then it should autofill for you. If you don't, then if it's not autofilled, then usually if you create an account, when you first log in, when you first go to Roboflow, it'll actually bring you to app.roboflow.com, which is kind of your personal workspaces. So I have a few set up already. I made a playing cards test, and to see your API key, you can hit this little settings and go to workspace settings and then Roboflow API. And then right here, private API key is the magic key that needs to go in the code. So if you need to, you can copy it and paste it in the code. But again, it should already be auto-filled for you. So what we'll need to do, so I have already copied from Roboflow, pasted it into my PyCharm IDE here. I went ahead and just folded my key here so we don't have to worry about redacting it, and just named it, RF playing cards 01.py. This is in my depth AI examples YOLO folder. I just kept it in the YOLO folder because whatever. And okay, so once you do that, we still need to, in the terminal, pip install Roboflow Oak. It will install the Roboflow package. Once you do that, we can go to town and test this out. So let's, I've already installed the library, of course. So let's do RF playing cards, spell it correctly, 01.py. Okay, I hear a little click of my device, and I see it's running. And let's go over, and there we go. Awesome. All right, it is running. It also, by default, it kind of runs this depth, shows this depth OpenCV frame, which I don't really want. But that looks pretty good. This I can see it's identifying these cards properly. Confidence, at least in this one, looks a little bit low, but it's still getting it. But we can see all that same info is printing down here. If we go down a little bit, so in the while loop, we have predictions, and in the comments here, it shows us all of the, this is a Python dictionary, so we've got key value pairs for all of the data that we're getting here, and then the predictions are being printed out right here. So it's got this little clever for loop that's going through the dictionary and then converting that to JSON in order to extract it properly and then printing it. But let's have a look. This is all kind of auto-scrolling craziness here. But in predictions, we can see, so it's got, we see in class here, I've got 6C, 6 of clubs, so 2 jack of hearts, right? So it's detecting that twice for each card here. Okay, so that works. It's great. I've noticed the more cards you put, the maybe more wonky it starts to get. So let's throw a couple more in there. Okay, so that's still pretty good. Can it do? Let's try to make this work really hard. Okay, is that getting it properly? Okay. I think it looks like it's getting all those pretty good. Helps to have a plain background like this. I just have a black piece of paper with the camera mounted above it. So that's all well and good. But of course, we want to send all that data and send video frames to TouchDesigner, right? So what we need to do is we kind of need to dive into this. So here's our data here. I want to find a way, I want to extract that data. I think this 4P in predictions for loop is where the magic is happening. And then parse it a little bit and then send it via OSC. So I've already combined that code here. I've added my libraries here and added, so for this case, actually, I made 3 different clients. Not necessary maybe, but I just wanted to send the OSC data to 3 different locations, 3 different OSC operators in TouchDesigner. So they each have different port numbers named at client 2, client 3. There's our NDI stuff again. And so right here, so that's where it's happening. So I just commented out this little print statement. So instead of having this in here, I was kind of feeling, okay, this for loop is what's going through and identifying those key value pairs from my dictionary. So I just kind of ran through that, and I'm grabbing the key called class, which is going to give me the value associated with that, converting it to JSON in order to extract it, and then giving it the name for my OSC channel of class. So you could do that for all of these, all those separately. Like I mostly cared about class right now, and then just kind of throwing in the exposition also. And then also I found it useful to send the number of predictions. So how many, how many 6 of clubs does it think? So if it's all one card, maybe it's sending 2 different predictions for the 6 of clubs, right? So that would give me a length of 2. So I just want to know, because that's going to help in my parsing in TouchDesigner, knowing like how many different predictions it thinks it is getting. So I'm sending that to 3 different OSC operators. So let's just run this bad boy. Let's do Python 3, and I called that. I just can't get my N's and my G's straight. Playing cards 02, and I kind of give this a really long name. Okay, I hear the click. It's running. So we still get this little window here, but what I care about is, let's go to our little home in TouchDesigner. Oh yeah, and I add a little sound too, because why not add a little chill sound. So let's just make this a little easier. Okay, now I got nothing there. Let's just do one of these. Okay, great. So I've got class being sent here. The number of predictions is being sent here. And then the X value of those is being sent here. I think actually I'm not actually using the X. I parsed it here, but then I decided not to actually use it. But it's there in case I do need it. So the reason why I wanted this number here, usually in your OSCN, this maximum lines would be showing 10 lines at once. So in that case, if I didn't have that, let's say, right? So this is showing me all these JHs, and so now I'm not even sure like how many cards are actually being displayed right now. So by looking at this data, there's really no way for me to tell. So by getting that length of the predictions, so I know there's only 2, then I can restrict my number of rows to just the number of things here. And I'm just using a deck with one deck, so there's only going to be 1 card possible. If you're using, let's say, like a 2 deck thing, you might need to figure some other way to identify, like, do I actually have 2 Jack of Hearts there, and only one icon is visible in each of them, therefore there's 2 JHs, or what? That'd be some further parsing that you'd have to do. But this looks not bad, so let's throw some more. Okay. So that's detecting it. So I'm kind of just getting rid of the bounding box and just trying to detect. There we go. Okay. So of course, I wouldn't just do that, because I've got this whole other situation happening over here. What if there's certain magic configurations of cards that lead to certain outcomes. So like in poker, you'd have full house, you'd have 4 of a kind or 5 of a kind or flush and all this straights, all that good stuff. So we need to train our system to kind of parse what cards are there and then figure out what is what. So basically this Dat Execute is reading whatever cards are here. So let's see, I've created a list called cards. So it's looking at the number of rows that this is coming in. And so filling my cards list with just the name of these cards. Let's actually make it a little bit easier. There we go. How's that? Okay, great. Okay, so in this case now we have 2 of each. Okay. And then, so what happens then? I don't care about this duplication. So this line right here that we see set. So this is converting the list, Python list, into a Python set. So one important difference in that is items in a set are all unique. So it basically discards these duplicates. So I end up with a list that's only 3 items long. So it has 1 2s, 1 QD, and 1 2D. It discards those other duplicates. And because that was just to, knowing I'm only playing with 1 deck, make that a little bit easier for all of my parsing here. And then creating a dictionary, separating the ranks from the suits. So how many queens do I have? How many 10s? How many 8s? How many diamonds? How many spades? All that stuff. So ranks and suits are different things. So kind of going through the list, and then also kind of trying to convert the letters J, K, Q, K, and A into actual numbers that I can parse with my chops further down the way. And then sending that data over to some chops. So we see that over here. Right, so these are my 3 ranks. So I've got a 2, a queen, and a 2. So we see, so 12 equals queen, a 2, and a 2. Beautiful. And I've got a spade, a diamond, and a diamond. So 2. So we got diamond, diamond, spade. Okay, cool. So my cards have been converted with this Dat Execute dat into chop values. And then really to figure out, okay, do I have any of these like magic combinations of cards? I'm doing some parsing in my chops here. So let's see what happens if I do some of that. Okay, great. So we had a little magic there. So this is triggering 3 of a kind. I've got expressions here that are testing to see if all these numbers are the same. Then that triggers 1. And we've got this little Quitter. So this is actually from the Italo Calvino story Castle of Cross Destinies, which I highly, highly recommend. It's all about kind of creating narratives out of card patterns. Okay. Let's try another one. Okay, so that's another 3 of a kind. So that was the same quote that was triggered. And that was a straight. And a royal flush. So we just built enough detection to detect those 3 things: 3 of a kind, straight, and royal flush. And that's it. So lots of options for other applications. For the things you're detecting, getting it into TouchDesigner is a fairly simple thing. It really, the complexity gets into your own personal application here in Touch, where to what extent, how difficult do you really want to make it in the way you parse things. Depends on what type of objects you're trying to get. So obviously with playing cards, there's lots of different variations that can be really complex. And so this was enough code just testing for those 3 things. But hopefully that showed you that it's possible. Okay, thanks.